All right, I'm back. Hopefully that helps things. Let me know, please, before I get started. I don't want to waste people's time. Blah, blah, blah. How are we? How are we? Can we hear? Does anyone hear me? Sounds good on one person's end. Okay, so I'm gonna keep going and hopefully no more issues. Okay. All right, I'm getting some good signs, so hopefully we don't have to do that again. I'm sorry for wasting time. Uh, the recorded version of this will now be missing that first part because I didn't have time to convert everything. So just in case, hi everyone, this is MDE 54, September 1st. We're doing stuff for week 2, and we're gonna pick up where we left off. We did number 1 in the homework really quickly, had some tech issues, and now we're gonna continue on with number 2. Thank you for your patience in this world of technological flubs. Gotta laugh at it, right? All right, so a man was born in 1882 and he died in 1954. About how old was he when he died? Now, they have a specific word up here, about, and that's because, as you might understand, as I hope you understand, people aren't just born in a year, they're born on a day. So let's say someone was born on January 31st, but they died on January 2nd. They wouldn't have hit their next birthday. And if you just blanketly subtract the years they were born in, you might not get their exact age. So let's say, just to keep the number simple, they were born in 2000 and then they died in 2020, sadly. But again, their birthday was January 31st and died on January, what did I say, 10th, 15th, something like that, either way. So even though if you did 2020 minus 2000, you would get 20 years old. That person only lived to be 19, 11 months, 19 years, 11 months and some change. So that is why they're using the word about here, because while that person who sadly died a little young, and again, only for the sense of just keeping the numbers small and simple, a few days before their birthday, you could still say they were about 20. They weren't exactly 20, but they were about 20. So that's what enables us to ignore the day and the month and just subtract 1954 minus 1882. And we get 72. So it sounds like this person, we'll call them Bob, lived to be about 72. They may have been 71 in some months. They may have been 72 in some months, but they were roughly 72 years old. So that's kind of like an estimate, but we never had to do any rounding. The rounding was already done in the problem by excluding the month and day of birth and death. All right, some friends drive around from town A to B to C to D. These are exciting town names. So from Portsmouth to Virginia Beach to Newport News to Richmond, whatever, and then back home to A, as shown to the right. So it kind of looks like almost one of those boring Midwest states. Sorry if you come from there. I don't mean any insult there, but just the layouts of the states are a little more boring. They're much more square-ish or rectangular-ish versus states like Virginia and North Carolina, who have a lot of our states' borders based on mountain lines. So they're not straight lines. They're very zigzaggy. That's what I mean by boring. So you go from A to B, which is 81 miles, then from B to C, which is 123 miles, C to D is 147, and then back home from D to A, 68 miles. You were making a round trip to see a bunch of friends in the land of COVID and wearing a mask and all that good stuff and social distancing. So we're just going to add these up. We just got to find, this is actually known as the perimeter of a geometrical shape. You just add up all the exterior lengths. So again, in the interest of not fighting my annotation, we've already lost enough time. 81 plus 123 plus 147 plus 68. After you hit enter, check your technology to make sure that you put all the numbers in correctly. Tons of students just want to see the answer, type it, move on without making sure it makes sense, without checking their work. And these are very important aspects. We have to learn to take our time. We have to learn to do things twice sometimes. Find the balance. So 81 was the first number, that looks good. 123, that looks good. 147, that looks good. 68, that looks good. 419, I think that answer makes sense. Let's try it out. 419. Check our answer. Good job. So before we move to the next one, let's say I had done this wrong. I was just messing around really quickly in my calculator or my TI-83 that I use digitally on my computer. If I hit a button too quick multiple times, it only reads one of the clicks. And I can't tell you how many times I've made that mistake where I go to try and type in the number maybe 66 and it only registers the 6. And then I get an answer and I go, well, hold on. That's not what I would expect for an answer. That doesn't make sense. It's too small or it's too big. And then I look at what I typed and I go, ah, you got me again, TI-83. You ate one of my inputs, is what you might say. So maybe I was just typing really quick and I went 81 plus 123 plus 147 plus 68. We gotta go. All right, it's 1,149. This is a red flag to me. I was adding up 2-digit and very small 3-digit numbers, and there was only a few of them, and I got a 4-digit answer. That just seems too big. So I go and I look at my work and I see, oh, I was rushing and I typed 811 instead of 81. These are the types of things you have to learn to act and react with. All right. The graph to the right gives estimates of the number of species for various kinds of insects. First question, how many more beetles are there than true flies? So beetles are red, and it says, let's read the whole thing before we actually do the math, about 400. True flies, as opposed to liar flies, I guess, 120. Then we want to find the total number of species for all the insects. Then we want to say, how many fewer beetle species are there than the species of the other insects shown? Question C might be a little weirder, so let's focus on A and B for now. How many more beetles are there than true flies? How many more means subtract. So we're going to do the 400 beetles minus the 120 true flies, and you should get 280. I'm not going to show that in the calculator. Wait, how did we get that wrong? To determine how many more species of beetles than there are of true flies, subtract the number of true flies from the number of beetles. Remember that the data entry graphs are in thousands. And this is what I was looking for right here, because we didn't completely pay attention, did we? So, and that was intentional. Again, I'm not going to say I'm always perfect. I make mistakes, but that one was intentional. And this is what a ton of students do. That's why I did it this way. They don't read everything. They read the question, they saw the numbers, they put the answer there, and then it's wrong because these numbers are in thousands. So this is really 400,000, and this is 120,000, which is a very, very large amount of insects. But hey, facts of life, right? So it's not 280 more beetles. We have to add 3 more zeros to that to make sure it's thousands. So 280,000. Now, they might attach the word thousand over here. So there are, the blank and then 1,000 in front of more beetles, in which case I would not have needed to type the 3 extra zeros. But spoiler alert, this course is going to do that to you very often, where they give you some regular old numbers in the graph, but they're actually in thousands or millions or billions, something like that. Check the answer. We got it right. Good. Sweet. So now we have it stuck in our head that these are all in thousands. So all of these have 3 zeros attached after them. The total number of species for all insect types is, total means add them up. And we'll do this in the calculator right quick. So 400 plus 260 plus 190 plus 120 plus 200. So if I just add up these 5 numbers alone, it's 1,170. But all of these have those 3 extra zeros attached to them because they're in thousands, which means this is not 1,170, it's 1,170,000. I didn't have to type these numbers with their extra zeros. I could have, and I still would have got the correct answer in the end. It's just I would have already had the 3 zeros there, but I know to attach them here. And let's see if the commas will work. 1 comma, 170, comma, 000. Let's see if that works. It does, so that's good. My math lab generally doesn't have a problem with commas. There are programs that do. But if you ever get an answer wrong because you put a comma in there, and it tells you you're wrong, but the number's correct. If it's a test, just let me know. That's, again, something I will absolutely give you full credit for. Because as far as I know, my math lab should allow commas or no commas for numbers like that. All right, last one. There are some number fewer beetle species than species of the other insect types. So we're comparing the beetle species, which are the red number here, 400, and we need to subtract that from the species of other insect types. So these are the other insect types, these 4 categories. So we're comparing these 4 grouped together to this one by itself. So what we'll need to do is add up these 4 values, and then we can subtract the 400. Well, in fact, I don't know why I just said that. So, and the species of the other types. So let's see, we got 260 plus 190. I prefer typing, but I like to use my mouse for teaching. Plus 120 plus 200, and we get 770. So there's 770,000 types of insects for these 4 groups, and we want to know how many fewer beetles are there, so we're going to subtract the 400. Let's see if this gives us the right answer. Let's see, maybe it will, maybe it won't. So 370, is that what we type? Just 370? Question mark? No, if I do that, it'll be wrong because we got to remember these are in thousands. So comma, 000, or no comma, drum roll, we got it right. What some students might accidentally do here is just think they're supposed to take the total of all 5 and subtract the beetles. But I did set it up correctly intentionally that we wanted to compare the others to this one. So we're not comparing the total to the beetles, we were comparing all the other groups to the beetles. The phrasing and the wording of things like that can be very important in a quantitative reasoning class in the real world as well. Find the area of the countertop shown in the diagram to the right. Here's a real world problem for some of you eventually. You want to replace the counters in your kitchen or your garage or somewhere. Maybe you got counters in your den or living room or bedroom with built-in cabinets and stuff. I don't know. But point being, we want to find the area of the countertop. When we say area, we're talking about the surface of the countertop because there's also the cabinets underneath, and that would be a 3-dimensional space, which would be volume. But we're just talking about surface area. So if you can see the coloration of this, it's kind of a bluish, purplish thing. I'm great with color names, obviously. That's what we're going to be figuring out. What is the area of this shape right here, ignoring all vertical aspects of this? And they give you all the important dimensions needed for this, believe it or not. You're missing 1 or 2, but you can find them implicitly as we'll discuss. So I will actually need to bring my annotate back for a hot second to do that. So we have this side is 83 inches. That's that 83 right there. We know that this side is 25 inches. We know that this vertical side is 160 inches. We know that this side is 44 inches. We know that this side is 25 inches. We know that this little cutout's 25 inches.